Okay, we can able to read information about snapshot record for each TTCs. So for we studied, right, for each TTC there will be a separate snapshot record stored, guys. So for every TTC there will be a separate snapshot record stored in the memory. Okay, so that later if we want to analyze what is the reason why this DTC was triggering or was logged or raised, we can able to identify by those parameter records. Okay, so what are the condition when this DTC was logged? We can able to see what was the vehicle speed, what was the voltage at that time when this DTC was logged, or so many other parameters. What was the temperature of the ECU? Okay, so by seeing these records, we can able to analyze later what was the reason why this DTCs was logged. Okay, and it will be helpful for reproduction of the DTC. If in lab, if you want to reproduce that DTC, those information will be helpful. Okay, apart from that, we can able to retrieve extended data record like occurrence counter or self-healing counter, or that DTC is there for how many hours. Let's say driving time is we drive the vehicle for 20 hours. For the 20 hours, that DTC was there. Okay, so those extra extended data record also we can able to retrieve, and that extended data record is also separate for each DTC. Okay, occurrence counter for DTC 1 will be stored in a separate location. For DTC 2, it will be stored in separate location. Okay, so if you want to read only occurrence counter for DTC 1, we can able to. If you want to retrieve occurrence counter of DTC 2, we can able to retrieve. Understood? So they are not sharing the common memory. Okay, they will be stored in a separate memory. So for which DTC information we want to, we can able to do that. Understood my point? And maximum how many DTCs can be stored at a given time, guys, for passenger vehicles? For how many DTCs memory are there? Memory are allocated. You seen na yesterday 8 DTCs. Maximum 8 DTCs information can be stored in the memory at a given time. If ninth DTC is also triggered, then one DTC memory has to be erased based on the priority for storing that ninth DTC information. Understood, guys? Have you understood, guys?
Sure.
Others? Understood now? Hello? Guys, have you understood? Maximum 8 DTCs information only can be stored at a given time. Okay. So now we will check few of the terms which are used for 19 service, like enable criteria, test pass criteria, test failure criteria, confirmed failure criteria, occurrence counter, aging counter. Okay. So these are the 6 terms which are most commonly used if we'll talk about faults. Okay. So what do you mean by enable criteria of a fault? So when a server or vehicle manufacturer criteria used to control when the server actually perform a particular internal diagnostic. So this enable criteria is when the diagnostic or self-test is run. Okay. So enable criteria talks about when the server is going to trigger the self-test or internal diagnostic. Understood? So as I told yesterday, few of the server which are critical, like power steering, braking system, they has to monitor constantly. While vehicle is running also, they will perform test and they will check all parts or all sensor, actuators, okay, CAN messages, everything should work fine while driving condition also. Okay. So their trigger or their enable criteria is every 100 millisecond or maybe every 500 millisecond, they will run a test to validate everything is working fine or not while car is running also. Okay. But for some issues which are non-critical like wiper or door window or light control, when you'll power on, that time only it will run once the test and will check whether everything is working fine or not. So when power on, it will perform the test, it will validate whether that ECUs, its parts, CAN messages, everything is working fine or not. After that, when driving, it will not perform the test. Next time when again powered off and on, then it will run a test. So for those ECU, the enable criteria is at the time of ignition on. Understood, guys? Understood now what is enable criteria? What about others? Have you understood?
Yes, sir.
Yeah. Now, if we'll talk about test pass criteria. So now, when a test or internal diagnostic is run, okay, so what will happen? The ECU will check each fault condition. Okay, let's say 600 faults are implemented in a ECU. It will check all 600 faults, whether that faults are logged or not logged, based on the test pass criteria and test failure criteria. Okay, so let's say one example. If a vehicle speed message is not present on the canvas, that means which node is responsible to send that vehicle speed information is not sending. Okay, due to some reason, maybe the wire got broken or something has happened. The CAN transceiver of that node is not working because of that. That node is not able to transmit the vehicle speed information on the CAN. Now, our issue, if it is not receiving that message for a particular time duration, it will consider as a timeout fall. Okay. So the issue run a test. Is this message received? Not received. Then it will fail the test. So that will consider as a failure criteria. So failure criteria is when the message is not received for this much time duration, that will be the failure criteria. And if the message is received, then that will be the pass criteria. Understood? So in the code will be written in such a way, it will check all the conditions. Okay. Let's say for voltage, there will be code written if the voltage received from the external power supply is less than 9 volt, consider as a low voltage fault. Okay. So now the pass criteria for voltage test is what? The voltage should be greater than 9 volt, right? Correct now? If the voltage received from the external power supply is greater than 9 volt, that will be considered as a pass criteria for low voltage fault. And the failure criteria for low voltage fault is when the voltage received from the external power supply is less than 9 volt. So that will be the failure criteria. Understood, guys? Hello? Have you understood this test pass criteria and test failure criteria? So the test will be run by the ECU to validate whether that condition is pass or fail. Pass criteria and fail criteria both will be defined by the requirement. Okay. Requirement we are deriving from the customer requirement. Okay. So now customer told in the requirement, if the voltage is less than 9 volt, consider as a low voltage fault. and when the voltage is greater than 16 volt, consider as a high voltage fault. Now, based on this requirement, we will drive test pass criteria and test fail criteria. So what will be the test pass criteria? Voltage should be greater than 9 and less than 16, right? Understood now? That will be the test pass criteria. The voltage should not be less than 9 and should not be greater than 16. If voltage is within the range of 9 to 16, that is test pass criteria. That means no failure detected. If the voltage is less than 9, consider as a low voltage fault. That is test failure criteria. The test is run, and if detected voltage is less than 9, that is the test failure criteria for low voltage fault. Guys, understood? What about others?
Yes,
What
sir.
about others? Have you understood?
Yes, sir.
Girls, no response from your side? Sleeping?
Understood, sir.
Sleeping, huh? Suddenly woke up. Yes, yes, understood. Understanding, right? What is test pass criteria? What is test failure criteria? Guys? Okay, now we'll see what is confirmed failure criteria. Now, as I spoke, this confirmation, that maturity time, we already discussed, right? When a test is run by the ECU and the test is considered as failed, okay? But it should be failed for some maturity time. That depends on the fault, okay? For some fault, the maturity time can be 0 milliseconds. Some fault, it can be 100 millisecond. For some fault, it can be 500 millisecond or 1000 millisecond also, okay? So when a test is run by the ECU and if the test is failed, and if the test is failing for this much time duration, then only that fault is called confirmed. That is confirmed failure criteria. Okay. When the server vehicle manufacturer or system supplier is specific failure condition that define whether the system being diagnosed is definitively problematic, means confirm, warranting storage of DTC record in the long-term memory. Okay. So if the fault is confirmed, then only that DTC record will be stored in the long-term memory. I told, right? If the fault is matured, then only DTC information will be stored in the long-term memory. If the fault is not matured, that information will not be stored in the memory. Understood? For some critical fault, this maturity time can be 0 millisecond. Whenever the fault is detected, immediately that can be stored in the memory. But some fault, it can be 500 millisecond. If the fault condition does not persist for 500 millisecond, the information will not be stored in the memory. Just keep it in mind. This is very important point. Fault confirmation. Okay. So if we'll talk about fault confirmation is very much important. Because once the fault is confirmed, then only the DTC information will be stored in the memory, or else the DTC information will not be stored in the memory. Okay, so that depends on the fault maturity time. Now, clear now? Fault confirmation. Guys, is it clear, right? Hello, am I audible? Guys, am I audible?
Yes, sir.
Clear now? Fault confirmation. Yes, no?
Yes, sir.
Okay, good. So now occurrence counter. So as we spoke, for each ignition cycle, if the fault is logged, that will be stored as a occurrence counter. How many times that fault has occurred? Okay. So a counter maintained by certain server that records the number of instances in which a given DTC test reported a unique occurrence of the test failure. Okay. So whenever a test is failed in a ignition cycle, okay, let's say today you turn on the ignition, you went for the drive and the fault has logged. Okay. Then the occurrence counter will increment to 1. Now you came home, turn off the ignition, हो गया. The next day morning again you turn on the ignition, went for a drive, again that fault has logged. Then occurrence counter will increment to 2. Okay. So this occurrence counter will maintain by certain servers that records the number of instances in which a given DTC test reported a unique occurrence of the test failure. Okay. So every time when you go in the ignition cycle and the fault has detected, that will be stored as a occurrence counter record. Understood? Guys? Understood now? So, guys, occurrence counter, is it clear or not clear?
Clear, sir.
Okay. Others, is it clear, right? Others, is it clear, right?
Yes, sir.
Okay. Now we'll talk about aging counter. So aging counter also we spoke earlier, right? A process whereby certain server evaluate past result of each internal diagnostic. Okay. So a process where the server will evaluate whether the test was fail or pass. Okay. Based on that, will determine, okay, if a confirmed DTC can be cleared from the long-term memory or not. So it's simple. When a test is run, okay, and when the test is failed, then the DTC information will be stored in the long-term memory, right? Yes, na? But when the test is fail, but when the driver went with the car for drive, okay, so when it went for drive and the test was again passed, matlab that DTC which was stored is not there, then it will increment the aging counter to 1. Okay, will increment the aging counter to 1. And what will happen? There is a kind of a threshold. Okay, some threshold is there. Okay, when that threshold is met, guys, when that threshold is met, let's say 40 or 256, just recollecting it, okay, then that whatever the DTC information is stored in the long-term memory can be deleted from the server. Okay, this is used for memory optimization because maximum 8 DTC's information at a time can be stored in the memory. Okay, so memory is very much limited. Understood? So if unnecessary that fault is logged only one time, and it's not logging for long time duration, 1 month, 2 months, 3 months, it is not required to store that information in the memory. Now the memory cannot be cleared automatically, right? Because to erase the memory, we need to go to the service center. Okay, so that's why we implemented a mechanism so that it will check the aging counter of the DTCs, and when the aging counter reaches the threshold, automatically ECU will erase from the memory. Self-erasing capability of the ECU or server. Understood? For that purpose, we have implemented the aging counter. Clear now? Guys, aging counter, is it clear? Hello? Guys, aging counter, is it clear? Not clear?
Okay, sir.
For everyone, is it clear, right? Girls, is it clear, right? Aging counter? Your silence, shall I assume it's clear or not clear? Guys, tell me. Okay, your silence is telling might be clear. Fine, we'll go ahead. We'll see this DTC status information. Okay. So, as I told, when a DTC is stored, okay, just tell me if my paint screen is visible or not.
Yes, sir.
Okay. So, when a DTC information is stored, okay, along with DTC number, DTC status byte information will also be stored. DTC snapshot record information will be stored, and this DTC extended data record will also be stored. Okay. So when a fault is triggered and when the fault is matured, okay, then that DTC number associated with that fault will be stored in the memory along with DTC number. DTC number is of 3 byte. Okay. Along with DTC status byte information, which is of 1 byte, will also be stored. Okay. And snapshot record data and an extended data record. So these depends on DTC to DTC. It can be sometimes 50 bytes or whatever. Okay, that depends on how many snapshot record. Okay, so these are not fixed. These bytes are not fixed. Snapshot record and extended data record, that depends on project and it depends on DTC. Okay, But this DTC number will be of 3 byte information and DTC status byte will be of 1 byte information. Okay. These 4 parameters will be stored in the long-term memory, NVM, non-volatile memory. Clear? Guys? Understood? These 4 information will be stored in the memory when a DTC or even a fault is detected by the ECU. And when the fault is matured, then only these DTC information will be stored in the memory. And using 19 service, we are going to read these information. Okay. So now this DTC number, some little bit, at least you understood, right? It will be 3 byte of, let's say, 01, 02, 03, 3 byte of information that will tell which DTC it is. Let's say this is low voltage failure. Okay. So once we read this DTC, then we'll come to know this was for low voltage fault. Low voltage failure. Okay. Now, this we understood. This 3 byte will tell what failure it is. What does this mean? We understood little bit about a snapshot record as well as extended data recall. Now, what do you mean by DTC status byte information? Okay. So we have 1 byte. Okay. 1 byte equal to how many bits? 1 byte equal to how many bits? 8 bit, right? Yes, no? Okay. So we have 8 bit of information stored. Okay. So now each bit will be of some information. ज्यादा हो गया. Okay ना? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So this DTC status byte information contains 8 bit. Okay. 0 to 7. Each bit shows, if this bit is set to 1, that means what? Okay. So that we'll see here. DTC status information. DTC status information is defined as the status of a DTC at the time of the request. DTC status, example, active, pending, etc. is determined by DTC status byte. So this status byte will give what is the status of that DTC when client has requested for reading DTC information. Okay. See, this point is very important. DTC status information is defined as the status of DTC at the time of the request. Okay. Because this DTC status will change with respect to time. Let's say client has requested to read a DTC status. Now, the DTC status can be different after 1 second or 2 seconds. If it is again trying to read DTC status, it can be different. Okay. So this DTC status information is defined as the status of the DTC at the time of request. When the client is requesting to read DTC information, at that time, what is the status of the DTC will be given by the server as the DTC status information. Is this point clear? Guys? So, see, there is a client, okay? Client has requested to read DTC information. Okay. when the client requested at that time, let's say client requested which all DTCs are logged. So server send DTC, let's say for low voltage, it's 0102, 01, 02, 03 DTC is logged, and its status at the time of request is, let's say, FF. Okay. FF means all these 8 bit are set to 1. Understood? Now, after, let's say, after 5 seconds, client has again requested to read DTC information. That time server will give 01, 02, 03, but now the status has been changed. Now it is FE. Okay. FE means now the first bit 0 is set to false. Other bit are true, but this bit is false. Understood? So this DTC information, when client has requested to read DTC information at that time, what is the status of that DTC? It will give. And this will change with respect to time. Okay. You will understand more once we'll go deep. Okay. Clear? So now, as I told, we have 8 bits. Is my screen visible, right? Guys, is it visible, right? Hello? Is my
Recording
screen
in progress.
correct now? Guys, am I audible, not audible? Hello?
Audible, sir.
Am I audible?
Yes, sir.
Okay. Because you guys are very silent. That's why. Fine. So this 8 bit of information, okay, this will tell what is the status of the DTCs. What is the current status of the DTCs? Okay. Bit 0 will tell whether the test is failed. Is that DTC active or passive? Bit 1 will tell test failed this operation cycle. Everything will go in detail, don't worry. But for time being, just memorize what is bit 0. Bit 0 means test failed. Bit 1, test failed this operation cycle. Bit 2, pending DTC. Bit 3, confirmed DTCs or stored. Bit 4, test not completed since last clear. Bit 5, test failed since last clear. Bit 6, test not completed this operation cycle. And bit 7 is warning indicator request. Each bit, if it is set to 1, that means test failed. If this bit is set to 1, that means test failed this operation cycle. If this bit is set to 0, that means test is not failed in this operation cycle. Understood? So each bit, if it is 1, what does it say? If it is 0, what does it say? It will talk about the DTC current status of the DTC. Is it clear, right? 8 bits are there. Each bit is having a separate information. We'll go in deep bit by bit. Okay. So now, first bit is test failed, bit 0. Okay. So this bit indicates the result of the most recently performed test. Okay. So as I told, the test is run by the ECU. Okay. And if the test is failed and when it is confirmed, then only the DTC information will be stored. Okay. So when the test is run and the test is failed, then this bit of that DTC will set to true. Understood? This bit shall be set to true or logic 1 when the most recent result from the DTC test indicated a failed result. The value must be latched until a new qualified result or retest is available. Okay, so just will go. Okay. Now, see, ECU is running test, right? Check, is there any failure observed? Okay. For this, what it will do? It will run a test. Run a test means it will look for conditions in the code. If voltage is less than 9, okay, then again check if it stays 500 millisecond. Then if both conditions are true, then store or trigger. See, fault will be triggered here only. Okay, if the voltage is less than 9, so voltage fault is equal to true. Okay, then once this is set to true, it will check for is it staying for 500 millisecond. Yes, then store etc information in memory. Okay. Now, if the voltage is less than 9, that means this test has been run and the test is failed. Okay. Then this condition will be satisfied, like the voltage is detected as less than 9. Here, bit 0 of status byte will be set to 0 or sorry, set to 1 or understood. When the test is run, okay, and the failure has been detected, that means the test is failed. Then bit 0 will be set to true. Okay. Now, this was just for, let's say, 10 millisecond or 20 millisecond. Okay. Next time again the test is run and this failure is not detected, then this bit 0 immediately will set back to 0. Understood, guys? Guys, have you understood? So this bit tell what is the current situation of this failure, if this is active or this is passive. Guys, is it clear? Yes, no? Guys, have you understood this? Hello, am I audible? Guys, please speak. Hello? Guys, am I audible? Have you understood this? What about others? Have you understood? Guys, have you understood? Sure, huh? So when a test is run, okay, so bit 0 indicate this bit indicate the result of the most recently performed test. Okay. So as I told, test will be run every 100 millisecond. Okay. Let's say in a ECU, critical ECU, test is run every 100 millisecond. So this bit will depend. If the test is passed, this bit will immediately set to false, or if the test is failed, then this bit will set to true. So this indicate there is an active failure. That means by seeing this bit, we can see like still this fault is there in the ECU. Okay, understood? The value must be last until a new qualified test. So this, if it is set to true, it will be set to true till next test is run. If next time the test is run, if it is passed, then this will set back to false, or else it will remain true. Understood? Guys, just a minute. See, one more time and try to understand, make you understand. Okay. Now, ECU run a test every, let's say, 100 millisecond. Okay. So now, first time it run a test for voltage. Okay. Low voltage check. And it detected there is an low voltage. And low voltage is, let's say, detected for 500 milliseconds. Then the DTC information will be stored in the long-term memory. And let's say DTC information is 010203. And the status byte detected is FF. Okay. FF means all the status bits are set to true. Okay. Now, this information is stored in the memory. Now, when the client read this information, it will get this DTC is stored in the memory and its current status is FF. Okay. Now, let's say after some time, that voltage problem was there, na? It automatically got resolved. For some reason, voltage got reduced to less than 9 volt. Now voltage is coming correct, 12 volt. Now this ECU is running test every 100 millisecond, right? So again, after some time, it run a test. Now test is pass. Okay. But this DTC information is already stored in the memory, and this DTC information will not delete automatically. Okay. Two conditions to delete. One condition is by sending command 14 service request, okay, to delete or clear all DTC information. Or else aging criteria is met. If the aging counter reaches 40 count, then automatically these information will be deleted in the memory. Delete from the memory. Understood? Now, if the test is run and the test is pass here, then what will happen? The status bit 0 will set to false. FE का मतलब क्या हो गया? 1111 1110, right? Correct now? So this bit 0 is set to false. That means now this DTC is stored in the memory, but this is not fail. Okay, the test is passed. Now this fault is not there now. DTC is already there in the memory because fault was there earlier. Now the test is passed. Now that voltage problem has been resolved. By seeing this bit, we can identify the fault is not there now. Understood, guys? Hello? Have you understood?
Yes, sir.
Okay. So each bit will give some significant information. Okay. So this is my PPT visible, right? So this bit 0, this indicates the result of the most recently performed test. This bit shall be set to true, logic 1, when the most recent result from the DTC test indicated a failed result. Okay, that means that DTC is active, that fault is still there. Okay, the value must be latched until a new qualified test. So this value will not change till when? When retest is done, if it is pass, then it will be reset to 0. If it is still fail, then this value still remain true. Understood? So this bit shall be set to false or 0 when the most recent result from the DTC test indicated no failure detected. So if the voltage failure resolved, then this bit will set to 0. Understood? And second criteria to set it to false is this bit shall be set to false when the clear diagnostic information command is requested. So there is one 14 service. If client has requested 14 service, then all the DTC related information will be resetted. It will be erased from the memory. Okay. So when the test is failed, this bit will set to true. When the test is passed, this bit will set to false. Or if the client has requested clear diagnostic information command, then this bit will set to false. Understood, guys? Guys, understood, na? Test failed means it will signifies every 100 millisecond test is running. If the test is pass for that fault, then this bit will set back to false. If the test is again failed, this bit will remain true. Understood? Guys, and there will be status byte stored in a memory for all the faults. Okay, for all the faults there will be a status byte stored in the memory separate, 1 byte information. 500 600 faults are there. For all 600 faults, 1 byte of information as a status byte will be stored in the memory. Guys, is it clear? Guys, guys, is it clear? Yes or no? Guys, is it clear? Okay. What about others? Girls, is it clear?
Yes, sir, it's clear.
Okay, fine. Now we'll see the next bit. So next bit is bit 1. Test failed this operation cycle. So this bit indicates a diagnostic test has reported a test failed result at any time during the current operation cycle. See, what do you mean by operation cycle? So when we'll turn on the vehicle, okay, you will sit in the car, वो की डाल के करते हैं ना, ignition on, right? So when the ignition on is done till ignition off, that will be considered as one operational cycle. Okay, it can be, doesn't depend on time. Let's say if you are driving continuously 8 hours, then your operational cycle is for 8 hours. If you turn on the vehicle, you went for 10-minute drive, again you turn off the vehicle, so your operational cycle will be for 10 minutes only. Understood? So this, yeah, so this bit indicates when a test is run and test is failed in this operation cycle. Okay, so see, uh, now here, is my paint visible, right, guys? Visible now? So now this bit is set to 1. That means this fault is when we turn on the ignition, we went for a drive. This bit is set to true. That means in this operation cycle, this fault was detected. If this bit is set to 0, okay, that means fault was there, but not in this operation cycle. The fault was detected way back, maybe previous ignition cycle or 1 day before or 2 days before. Now in this operation cycle, this fault is not detected. And now also this fault is not there because bit 0 is also set to true. That means the test is pass. And in this operation cycle, the test is pass. Understood? This DTC is stored in the memory, but it was not in this operation cycle. Now also this fault is not there. These 2 bits, if it is set to false, that means now the test is run and test is pass, and test is run and pass in this operation cycle. Understood, guys? And now let's say again after some time, the test is run and test is fail. Okay, so then this bit will again set to true. Bit 0 will set to true. Okay, because now test is run and test is fail, and this bit 1 is also become true because in this operation cycle this test is failed. Understood, guys? If in the current operational cycle test is run and test is fail, then this bit 1 will set to true. Understood? And this will remain set to true for the complete operation cycle. Now let's say again test is run and test is pass. This bit will set to false, but this bit will not set to false for this operation cycle. Okay? Understood? This depends on the current status of the test. If current status is pass, this bit will set to false. If current status is fail, this bit will set to true. Okay? But this bit 1 depends on the operational cycle. Now in current operational cycle, this test is failed, then this bit will set to true. For complete operational cycle, this current complete operational cycle, this bit will set to true. When this bit will set to false? When we are turning off the ignition, turning off the ignition and turning on back, okay, and the test is run and test is passed, then only this bit will set to false. Okay, now for next operation cycle, when fault is not detected, this bit will reset to 0. Is it clear, guys? Everyone, is it clear?
Yes, sir.
Bit 0 will tell what is the current status of that DTC. Okay. Every 100 millisecond test is running. If test is pass, this bit will set to false. If test is fail, this bit will set to true. Okay. But this bit will tell for this operational cycle what is the status. If one time also this bit is set to true in this current operational cycle, so this bit will not set back to false in the current operational cycle. This bit will be set to false in the next operation cycle. Understood? Everyone, have you understood?
Yes, sir.
Okay. So this bit shall be set to true. Is my PPT visible, right?
Yes, sir.
So this bit shall be set to true when the test field is set to true. When this bit 0 is set to true, immediately this bit will also set to true. Okay. Because this bit is set to true when test is failed. And this bit will set to true, test is failed in this operation cycle only, right? Correct now? So when this bit is set to true, immediately this bit will also set to true. This bit shall be set to false when a new operational cycle is initiated. Okay. In this operational cycle, this bit will not set to false. When again we come back home, turn off the ignition. Again, next day when we are turning on and the test will be run and test is passed, then this bit will set to false. Understood, guys? Okay. And another criteria is when we are sending clear diagnostic command. Okay. So the command is 14 FF FF FF. If client is sending this command, this also we'll see. Okay. Next, after 19 service, we'll see 14 service. Okay. 14 service is clear diagnostic information. If the client is sending 4 byte of command 14 FF to the server, server will erase its complete DTC information. All the DTC information will be erased from the memory. Understood? So all the DTC information means that status byte information also. Understood? So that's what it is telling. This bit shall be set to false when clear diagnostic information command is requested. So when client is requesting that command, this bit will set to false. Understood, guys? Understood now? Okay. So now we'll go to bit 2. Okay. Bit 2 is pending DTC. Okay. So pending DTC means this bit indicates whether or not a diagnostic test has reported a test failed result at any time during the current or last completed operation cycle. This status only updates if the test runs and completes. Okay. The criteria to set the pending DTC bit and the test failed this operation cycle bit are same. So this pending DTC is when the test is failed. Okay. And when the this bit is confirmed. Okay. When the test is failed and when the bit test is failed confirmed, then this bit 3 will set to true. But until then, pending DTC will be set to true. Okay. See, I told right, there is a fault maturity time, right? When test is run and test is failed, then this bit 2 is set to 1. Okay. When test failed bit, that is bit 0 is true. Okay. Immediately this bit 2 is also set to 1. Okay. This indicates the fault is there, but it is pending for maturity. It's not matured. Understood, guys? The fault is there, but it is not matured yet. So that's why this pending DTC will set to true. Guys, have you understood this? When the test is failed, bit 0 bit is true. Immediately this bit 2 is also set to true. Okay? This bit shall be set to false after completing an operation cycle during which the test completed and the malfunction was detected. Okay. So in next operation cycle, when the confirmed DTC is set to true, then this bit will set to false. Understood? When this bit will set to true, this bit shall be set to true when the test failed. That means test failed bit is bit 0 is set to true. Immediately this bit 2 is also set to true. And this bit will set to false when the fault is confirmed. Okay? When the fault is matured, then this bit will set to false. Understood, guys? Guys, have you understood?
Yes, sir.
Everyone, have you understood? Pending DTC means still the DTC is pending for confirmation. Okay. Fault is there, but it is not matured. So it will tell that. Understood? Now the bit 3. So again, the false condition is clear diagnostic information. If 14FF request is made by the client, this bit will be cleared from the memory. Okay? Understood, guys? Yes, now? Yes or no? Okay. Now we'll go to confirmed DTCs. Okay. So see, confirmed DTCs depends on two criteria. Okay. One criteria is for trip one trip and two trip DTCs. Okay. First, understand what do you mean by one trip DTCs and two trip. Okay. Trip 1 DTCs. Okay. So what do you understand by trip 1 DTCs? Okay. Guys, what do you understand by trip 1 DTCs? Where maturity time is 0 millisecond. Understood? When a fault is detected, I told now critical fault, critical failure. When the failure is detected, immediately it will be stored in the memory because the maturity time is considered as 0 millisecond. Remember, guys? Guys, remember? So one trip DTC means immediately the test is run and test is failed. Immediately this confirm bit will set to true for trip 1 DTCs. Trip 2 DTCs where there is some maturity time. Let's say 500 millisecond or 100 millisecond, like that. So for trip 2 DTCs, when the fault is matured, then only bit 3 will set to true. Okay. Test is failed, but test is failed for 500 millisecond, then only confirmed DTC will set to true. Till that 500 millisecond, bit 2, which is pending DTC, will be set to true. Guys, understanding this? This is bit tricky, I understand. It's very difficult to understand also. I know that, but I'm trying my best to make you understand at least 30-40%. Guys, the second time we'll do revision, na? That time it will be more clear. But my intention is, are you able to understand at least 30-40%? Guys, understood, na? So there are two types of DTC. One DTC whose maturity time is 0 millisecond. Okay, those are critical DTCs. Immediately fault is detected, it will be stored in the long-term memory. Some DTCs, it may have maturity time 500 millisecond or 100 millisecond. Okay, so this confirm bit depends on this maturity time. For the DTC whose maturity time is 0 millisecond, immediately fault is raised and bit 0 test failed is set to true. Immediately that bit 3 will also set to true. Okay, but for trip 2 DTC depends on the maturity time. When bit 0 is set to true, this bit will not set to true. Okay, that for those DTC, bit 2 will set to true first, and after maturity time only, this confirm bit will set to true. Clear? Okay, so so this bit indicates whether a malfunction was detected enough time to warrant that the DTC is stored in long-time memory. So that means this bit indicates whether there is a maturity time or not. Okay. This bit is supported differently based on one trip and two trip DTCs. Okay. A confirmed DTC does not indicate that the malfunction is present at the time of the request. Okay. So now if we'll talk about for trip 1 DTCs, this bit shall be set to true when bit 0 test fail bit is set to true. Okay, trip 1 I told now maturity time is 0. So when bit 0 is set to true, immediately this bit is also set to true because maturity time is 0. But for trip 2 DTC, this bit shall remain false when bit 2 pending DTC is set to true during first trip. So pending DTC will be set to true immediately, right? Pending DTC will tell the fault is there, but it is not confirmed. Okay. Understood, guys? Fault is there. If the pending bit is set to true means fault is there, but fault is still not confirmed. And when the fault is confirmed, then pending DTC will set to false and confirmed DTC will set to true. Understood? Guys? Everyone? Is it understood? Guys, what about others? Have you understood this?
Yes, sir.
Okay. Now, when this bit will fall, set back to false, this will not set back to false by its own. Okay. Either if self-healing or aging criteria is satisfied, then aging criteria is satisfied with, then that DTC related information will be deleted from the memory, right? So in that scenario, only this bit will be set to false. And when a client is requesting clear diagnostic information, so in these two scenario only this bit will set to false. Understood? So once a fault is confirmed, that information will not be erased from the memory. Okay, until aging criteria is met. Okay, and sorry, or clear diagnostic command is requested by the client. Understood, guys? Okay, good. So next bit 4, 5, 6, 7 we'll see tomorrow. Is it okay? I don't want to give more load on you. These 4 bits only difficult to digest. Okay. At least understood, na? Are you able to understand? What about others?
Sir.
Okay, na? Is it clear, right?
Sir.
Okay. Just have you written notes for this? Guys, everyone written, na? Just do revision. And tomorrow just come up with some question if you didn't understood. Okay, na? Do revision. This is very important. Okay, this 19 service is very important. If you go for interview, 19 service, if you'll explain good, you will get selected. 19 service is very important. Okay.
Yes.
So if you are not able to understand, ask me again and again. We'll go slow for 19 service, not a problem. Instead of taking 5 days, I'm ready to invest 7, 8 days also. But my intention is you should understand 19 service request well. Okay, now?
Yes.
Everyone, is it clear?